This is probably the most dangerous creature in the world. Aedes aegypti, the yellow fever mosquito. It is the main transmitter of viral diseases such as Zika, yellow fever, or dengue. One study of dengue viruses estimates that half the world's population is at risk of infection. But that could soon be a thing of the past, thanks to this man. British zoologist Luke Alfie developed a powerful weapon against Aedes aegypti, based on an old idea: death by sex.
So the basic concept is very intuitive. If we could release a lot of sterile males into a population that has normal males and normal females, well, those wild females will have no or fewer offspring than they would have had because they've mated a sterile male instead of a fertile male. Then the target population will decline and collapse over generations.
This so-called sterile insect technique has been used since the 1950s. Insects are rendered sterile using radiation. But there are many disadvantages too, especially with mosquitoes.
We can't target the radiation just to the sperm or just to the testes or something like that. So we inevitably irradiate the whole insect, and that damages all the other cells, and that weakens them.
So Alfie and his team are developing an entirely new approach. Instead of irradiating the yellow fever mosquito, they're changing its genetic makeup. They inject tiny amounts of a genetically modified gene into the mosquito eggs, with a sterility program stored inside it. The larvae in the egg absorb the foreign genetic material and copy it into their own DNA. From just a few of these modified eggs, the researchers breed millions of male offspring, all of them easily distinguishable thanks to a built-in luminescent gene. Then the lab mosquitoes are released. To be effective, modified males are released in a ratio of 10:1 to wild males. Wild female mosquitoes will then most likely choose the sterile males as mating partners.
There are many ways to control insects, and the best known ones are probably chemical insecticides. But of course they have quite significant off-target effects. The species specificity of genetic control make them ideal for sensitive ecosystems.
Alfie's lab mosquitoes have been used in pilot studies in Brazil, Malaysia, Panama and the Cayman Islands since 2009, with great success. They have destroyed the local yellow fever mosquito populations by 90% and more. Female mosquitoes bite and spread disease. Researchers can adapt specific genes so that female offspring die while the males live on. In classic heredity, half the genes of the mother and father are passed on respectively. The sterility gene is passed on by the male offspring, but only by 50%. So within a few generations, the program disappears all by itself.
It makes the methods very controllable, very local, very reversible. If you stop releasing it, it will disappear very rapidly. The disadvantage, of course, is that if you stop releasing it, it will disappear very rapidly, which is so you have to keep on releasing if you want to have the effect.
Alfie applies for a patent for his method, and in 2002, from Oxford University, he founds Oxitec, which uses its technology to treat yellow fever mosquitoes and other insects. In 2015, he and his team are nominated for the European Inventor Award.
Those awards are really important, and more so than I used to realise. So there's real value in the patent system, I should say, to start off with, that we could never have done what we did, start a company. You can't do that unless you have some sort of control or ownership of the technology. If you imagine a world with no patents, your only alternative is to keep everything secret.
A few months after the award ceremony, Oxitec sold for $160 million, and Luke Alfie left the company to devote himself entirely to research. At the Pirbright Institute, he continues to develop his gene sterilization technique. With so-called gene drives, it should become even more efficient. Gene drives ensure that the changed bit of the genome is 100% rather than 50% inherited, and can thus establish itself permanently. Well, in theory at least. The sterility gene is passed on and cannot be stopped until all yellow fever mosquitoes on the planet have disappeared. An extreme scenario, and not what Luke Alfie is aiming for.
I don't think there are very many species where you want to homogeneously modify the entire species. You could imagine a genetic system which will invade and persist in one population, but not then invade adjacent populations. We might call that a local or localized gene drive system. And that's really what my current research focus is.
So researchers could incorporate genes that only activate the sterility program under certain local conditions, for example. Or other programs are attached to the gene drive, such as genes that render a virus like dengue harmless when it is ingested by the mosquito. So far, local gene drives like these exist only in theory, and research into them is strictly limited to the laboratory. But for Luke Alfie, they harbour fascinating possibilities.
This is a really exciting time. We've just scratched the surface. We're just at the beginning. This is a fantastic time to be an innovator in this field.
In the future, Luke Alfie's inventions might even defeat dengue or yellow fever permanently.